knowledge and practical insights that can be applied into your own teaching and research endeavors. As we look forward to Roy's session today, I would like to also remind everyone that our esteemed principal, Dr. Partho Sarkar, will be delivering the valedictory session today. We are privileged to have Dr. Sarkar with us to share his insights and reflections on the week. His address will be the perfect conclusion to this successful program. Please note that we need all participants to stay joined until 5 p.m. Dr. Sharkar's words of wisdom will provide motivation and inspiration as we conclude this enriching session today. Professor Roy has completed his PhD from the Department of Mathematics, Vishwabharati, in the year 1994. After that, he worked as a postdoctoral fellow to develop some scientific software in the university level, Quebec, Canada, during 1994 to 1996. After the completion of the postdoctorate fellowship, he joined Indian Association for the Cultivation of Sciences, Jadavpur, Calcutta, as a scientist pool, and he accepted the job of assistant professor in computer science in Vishwabharati in 1997. Subsequently, he worked as a visiting faculty in the academia in Taiwan during the period 2002 to 2003. The Department of IT, Assam University of Silchar, appointed him as a professor in February 2008. Presently, he is a professor and former head of the Department of Computer and System Sciences, Siksha Bhavana, Vishwabharati, with 26 years of teaching and 29 years of research experience. Presently, 7 research scholars are working under his supervision. During this tenure of his career, he has published more than 100 research articles and papers in various journals of national and international repute and filed 1 international patent. 6 PhD students have already been awarded under his supervision, and they are well placed in India and abroad. As a principal supervisor, he has handled externally and internally funded scientific projects. He has been delivering keynote speeches, invited talks, special lectures in various national and international seminars and conferences, and in various institutes of the country since the last 15 years. He has worked as a chancellor nominee in the Department of IT in the University of Jadavpur, University of Calcutta, and Maulana Abul Kalam Azad University of Technology, Macaut, Calcutta. As a subject expert, he has worked in various state and central universities many times. As a recognition towards the academic field, Indian International Society, an NGO in New Delhi, awarded him the Gaurav Bharti Award in 2017. So, without further ado, please join me in welcoming Dr. Utpal Roy for his session in Future Trends and Research Opportunities. Thank you, and let's make the most out of today's session.
Thank you, madam, for your nice introduction. I am really proud of it. At the same time, good afternoon to all the participants. I understand everybody is a faculty in either colleges or universities or various institutions. I am also an academic faculty, so I have regards all of you. Let me start with my transparencies to upload. So here, am I? Let us start from the beginning. I have to share it now first. Just a moment. Just a moment. Okay. Let me share it entire screen. Am I audible to you? My transparencies are visible? Yes. So, okay. Thank you then. The title of my talk is Future Trends and Research Opportunities, Keystroke Dynamics and its Application in Healthcare. Uh, this talk, the content of the talk is supported by Dr. Shomen Rai, my mm, PhD student. So, in this talk, I shall tell you one thing that nowadays it has already been established that typing pattern of a human being in keyboard or in touchpad or in mobile phone touch screen is very unique from person to person. Due to this uniqueness, this typing pattern nowadays has been considered as a biometric. Biometrics always use here for the recognition, authentication, and identification purposes. This keystroke pattern can be caught, can be catched effectively with the smartphone or laptop or any other sensor devices. We all know that our smartphone that we always handle has the ample number of powerful sensors. These accelerometer, gyroscope, gravitometer, proximity sensor, light sensor, and many other sensors may be varies from phone to phone and according to its compactness. So, with the help of these smartphone sensors, while we are handling smartphone, while you are typing on the touchpad or touch screen of the smartphone, or we are moving with the smartphone, all the activities, body languages, typing pattern can be caught very effectively, very accurately, very cost effectively without investing any cost or any other hardware specific to catch it. If we can analyze this histodynamic pattern or analyze our movement pattern, analyze our body language, many things can be detected very accurately. This accuracy of these smartphone sensors is up to the order of 10 to the power minus 9 second, of the order of nanosecond. Throughout this talk, throughout all of this talk, I shall just teach you, I shall just tell you, I shall just try to describe in front of you how this keystroke pattern, how this phone holding pattern, how this walking pattern, how this human gait can be caught with the smartphone sensor, and after analyzing it, we can detect gender, the age group, the handedness. Handedness means whether I am left-handed or right-handed. Hand use, how many hands I have used, and various other motor neuro disorder like say Parkinson, dementia, Alzheimer, everything. So throughout this talk I shall tell you, try to describe, try to present before you how with this smartphone technique these can be detected, can be analyzed so easily. So come to the point, what is keystroke dynamics? Keystroke dynamics describe how a user types on a conventional keyboard or touchscreen or touchpad to authenticate the user. Nowadays, it has gained popularity due to availability and affordability of smartphone devices. High penetration rate and rich features provides opportunities to develop access control mechanism to secure healthcare data and to extract useful information for screening, test, and Parkinson disease. So, this is the comparison in performance. So these two parameters you maybe know. We shall measure the accuracy of this histoc dynamics performance with the parameter equal error rate. Equal error rate is the point where the falsely rejection rate and faulty acceptance rate meets together. This height is called equal error rate. This is the measure of accuracy. If the equal error rate is more and more less, your model is more and more accurate. As it is less, your accuracy is high. So as a study, it shows that fingerprint is the most more has more accuracy, and keystroke dynamics false acceptance rate is 0.1%, false rejection rate is 3%, and facial recognition system, speech, etc. This according to the accuracy, if we arrange it, we shall see that keystroke dynamics is the second one. It can produce much accuracy. Okay, it can be used so easily. This is my objective to say. Feature sets. So while typing on the keyboard or on a smartphone, there are some features vectors. You have to extract some features vector. Many features vectors you can define. Out of this, we shall use some specific ones that can be mostly important for our purpose will be considered here. The key hold time, how much time, say if I press A, B, if I type A and B, I just first I just press A, then hold A for few millisecond or nanosecond, whatever you can say, then I release A. So this thing is a hold time, key hold time. So while typing A and B, this time, this key hold time, this is pressing to press to release. This total time is key hold time. This is the key up down time. This is up time. Okay, these are the various features vectors, or you can say the timing features vector, or the timing features during typing on the keyboard or smartphone or touchpad or in a touch screen that is generate this type of some feature vector. After typing something, some words, some sentences, some numbers, we will extract these timing features. Okay, then these are, here is the features vectors. With this features vector, with the help of various machine learning algorithm, we shall analyze all these features vectors and extract some result that will be much interesting for us. That will be gradually I shall come all these points. Suppose if I take type say Kolkata, okay, Kolkata 1 to 3. So if I type it here, Kolkata 1 to 3, this K, this is press time, release time, press time, release time, press time. These are the various timing features we have calculated. We have extracted it from the smartphone. I'm just typing a word Kolkata 1 to 3, suppose it's a buzzword. Okay, so it's press time and release. This is order of millisecond. Okay, so these are the various features vector one can easily calculate. Okay, if the Ri, Pi, Ri plus 1, Pi plus 1. Oh, these are the various timing. This Ri is here, Pi is here. Pi is press time, Ri is release time of a key. So these are the down key latency, up key latency, down up key latency, total time, digraph, trigraph, many other features vector you can design according to your need to increase the accuracy of the analysis, etc. But very difficult to handle large number of features vector at a time. Sometimes it becomes useless. Okay, so here for the purposes, all these maximum, all these 8 features vector we have considered here. So these are the nature of various Within our smartphone, there are so many sensors, rotation sensor, accelerometer, time sensor, gyroscope, proximeter, light sensor, many other sensors. These sensors are very accurate. Working gyroscope means it gives you 360-degree motion. It keeps the record of the mobile phone of its 360-degree motion. Okay, the time accelerometer measures the acceleration of the smartphone in various directions. Various directions. This is the rotation sensor. In a chip board, in a chip, all the sensors are installed, kept in this way. So these are the keystroke dynamics added features: alpha detection, beta detection, gamma detection. Now, in histodynamics mode, there are two type of mode. Normally, we shall consider here on static mode. You will text a very fixed text, simple text, maybe complex text or numeric text. That is a fixed static mode. Okay, that is the static mode. So you will type your password, say Calcutta XYZ at the rate, say only Santiniketan. This is the whole static mode. Dynamic mode means any long text, any text you can type any type. That is the paragraph, maybe long text, maybe any random text. Okay, this is the mode of operation of histodynamics. I shall come to the point. Histodynamics based design. It can be used to verify. Okay, okay, verify out of many users whether you are not out of, you are the valid user or not. Decision is used or not. This is called very static mode. Restricted input. Okay, single user sample has been stored in the database. When the user come and type, give some keystroke pattern, that keystroke pattern will be compared with the stored sample with some reasonable accuracy. What we would like to say with this thing, with this term, that the all the times your typing pattern may not be same, but how much error you will error, that is depends upon your measuring parameter equal error rate. Equal error rate is verification in static mode, verification in dynamics mode. Maybe you can type a static text, your password, fixed password. You can type anything. Your typing pattern, one machine will see your typing pattern, it will identify you, whether you are not, you are anything else. This is verification mode. Identification mode, the multi-users samples have been stored there. Out of this multi-users, okay, you will be detected who are you, whether you are one of those or not. If you be one of those, out of this one, two, three, four, five, who are you? Well, number one, number two, number four, or number five, or anything. So multiple sample has been stored within this database, and it will work in a identification in static mode and identification in dynamic mode manner, and the measuring parameter is accuracy. If you say if the accuracy becomes say 90% or above, you will allow it. You say if accuracy be 99% or above, then you will allow it. But at the same time, you have to remind your typing pattern all the time is not same. It depends upon many different environment, your mental state, what you are going to type, what is your outside means surrounding environment, where are you in the train or in bus or in flight, whatever, everything incorporates your typing. So accuracy will be adjusted according to your system. You can say that if 88% accuracy will allow people authenticate the user. Prediction mode. You can predict many things with the typing pattern. The prediction mode is very important. What the things you can predict many things. One of these, you can predict some motor neuro disorder with the help of typing pattern. With the typing pattern, you can use whether you are a left-hander, right-hander, your age group, okay, your education level, whether you are lying or not, your gender even, your mental stress that can, everything can be analyzed according. This parameter is area under the curve. Okay, okay. This area under the curve is the parameter. What is area under the curve? I shall come. So this is verification static mode, verification in dynamic mode, items in static mode, identification mode, prediction in static mode, prediction in dynamic mode. All these things, it has been studied that all these things we can predict. So these are the three things can be used very effectively in modern day IT world for the purpose of verification, identification, and authentication, also in prediction. Okay, next come to the next slide. Keystroke dynamics where access control use of an anomaly detector. Anomaly detector user authentication. This can be done in two ways. Okay, knowledge base. When you know something, means you know your PIN number, you know your password, you know your graph pattern. So with the PIN number, password, and graph pattern, you can with knowledge with that you know. Okay, you incorporate your knowledge with some that you have. What you have? You have the marker, secret key, context. Within this, you can make this two-way authentication technique. And above with this, the biometric authentication technique. Out of the biometrics, you know that there are some physical biometrics with which we have already born the face, fingerprint, iris, hand geometry. Okay, these are the physical biometrics with which we have born. We have acquired this from the birth. Behavioral parameters. We have acquired in your life, day-to-day life in behavior, say your handwriting, signature, your voice, your gait, and importantly, that is the point of concern here, keystroke dynamics, keystroke pattern. Keystroke pattern is most useful and important here. Why it is so? It can be caught easily. It can be caught very effectively. It can be stored very effectively for a long time and can be analyzed with various machine learning algorithm, conventional machine learning algorithm to develop access control, security of the system, etc. Nowadays, we can think that our health parameters are people's things are all confidential. If keystroke dynamics be used for security, your health parameter will remain secure. If you have a system, if you can give the typing pattern that can predict whether you have your Parkinson, Alzheimer, or dementia, or any other forgetfulness that can be studied, detected in keystroke pattern. So this access control confidentiality would be restricted with the keystroke dynamics. General background. Say this an anomaly is an unexpected pattern that differs from the majority of pattern or the normal pattern. Anomaly detection methods are used to detect anomalies, unauthorized attempts in the keystroke pattern streams. Keystroke-based user authentication is identified as anomaly detection problem. Say this is the say typing pattern. Okay, this diagram figure shows typing pattern. This is the variation, range of variation. How much amount will allow? This is the variation should be there in your typing pattern. This is obvious. If you type something now, if you type same thing after 5 minutes, this two will not be the same. That has been easily examined. That has been examined, is well proved. There should be some variation. So how much variation you will allow? Okay, this orange color is the template one. This is your keystroke pattern template. Okay, this is the pattern you have typed now. This genuine one. This is saying in the color of blue. This some temporal changes. Temporal change may occur. This change is not less. Change is very high. It's temporal change. But but around this genuineness, this is the width of accuracy that you will allow. This anomaly. Okay. So this is the error. Up to this much amount of error you will allow. Okay, for a case. So this is under your hand. How much you will adjust your system, how much percentage of error you will allow. So this is the variation in typing pattern. Nature is like this. So we consider this average one in this way for our acceptance rate. Issue and research gaps. Significant challenges of anomaly detector performance in changing dataset and evaluation conditions. Top anomaly detectors are varied across the studies. Top anomaly detector varies across the studies means all the studies for all type of studies, same anomaly detectors. Anomaly detector I here mean a binary class classifier is considered yes or no. This binary class classifier I say here is anomaly detector. So come to this point in detail. Code reproducibility, reapplicability, and code reusability crises in reevaluation in same assessment setting. These are the issues and research gap. Research gap and continuing implementation and and re-evaluation large number of anomaly detectors with large number of unique data set in the same assessment setting. Compare the anomaly detectors effectively towards the top detector selection. Identify the influencing factors for uncertainty in the detector's behavior. Identify the influencing factors for the uncertainty in detector's behavior. Here, a lot of dataset of keystroke dynamics are available in literature and also with my group. My group with 7 students, research scholars are working in this field. So we have our own data sets also. The last one, Roy Keystroke 21. This is our data set. Our laboratory is very balanced, very efficient and large amount data set. The letters here are of their own. So this is the features. Only we have considered timing features. Here we have considered only the sensory features of the smartphone during typing. Okay, this subject is 87. 87 volunteers have been contributed their data in the data set. Review set is 6. At a time, they have typed the same thing in 6 times. Say you have typed Kolkata. Session is 2. Means suppose I ask one volunteer to produce his data in the morning. Maybe after 7 days I ask him to produce the same data. So in the morning I ask him to type 6 times. After 7 days again I ask him or her to type 6 times. So after 7 days, these 2 times the 2 is the session. This session you can increase and number of typing repetition you may also change according to need, but all the times number of you may normally think that if we increase this repetition accuracy will much increase, lot of variation will be captured. It is not so correct statement. It does not always mean. We shall come to the point. Sessions means number of times we shall ask him or her to type, that will increase the accuracy, but it is not always the case. This is Q at this last column is the device. Q stands for quadtree keyboard, A stands for agility keyboard, N stands for Nexus 7 tablets keyboard, NS stands for Nexus 5 mobile phone keyboard, maybe M, Moto G for typing pad. So these are the various things. We have studied with 50 anomaly detectors, means 50 binary class classifier. Out of this, we have used the Art Studio. Art Studio, Art Studio gives the better visualization of data. We have prepared the box plot. These are the all box plot with various type of or with various type of anomaly. The textures in the right side, you see all of these are data set. These are the various data set we have used. These are the result. Y-axis represent equal error rate. X-axis represent various data set. This is the box plot. This box plot, this middle black line is median. Okay, middle black line is median. These data are outlier count, and this is the variation. Standard. This word is standard deviation here, and this upper number is the mean. So this can easily be done with the Art Studio, and analysis has been done with Art Studio. We have chosen the Art Studio because Art Studio gives better visualization of data. Let's come to the next point. Slide performance. So out of these various anomaly detectors, we have checked the scaled Manhattan perform well in this case. Scaled Manhattan out of all these anomaly detectors perform very well. And these are the result of these all various anomaly detectors. These are the various data set. This value, the scale Manhattan, this value is the equal error rate value. This is the p-value. P is a statistical parameters. This p-value varies between two anomaly detectors with 0.05 less than 0.05. Then you have to think that these two detectors has their variation in their performance. Come to the point. This is the ROC. Receiver operating curve. For this three, autoencoder is red, outlier count, outlier is green, and this is the blue scale Manhattan. Area under the curve is another parameter that I have taught you already. So factors that influence the typing pattern. Factors that influence the typing pattern. All type of character set does not yield same result. There are some character set that can affect. So the complex complex text has a numeric, non-numeric, alphabetic together, capital, small. This is called a complex text. Performance is like this for the complex text. Okay. Numeric test only now 1, 2, 5, 6, 7, 8, 9. If you type all this is the nature of box plot, and this is the simple test. Only say Calcutta, something I shall go home. It this type of simple test. So depends performance depend on nature of the text you are going to produce for keystroke dynamics pattern. Now. Here, comparison for the feature arrangement. What are the feature vectors that influence much the typing pattern? The typing pattern evaluation, keystroke evaluation. Say all features that we have told: key hold time, up time, up down time, down up time, down time, etc. All the performance is like this. You have to think of the equal error rate. Okay, the performance is this. So in case of hold time, out of these down latency, up down latency, key hold latency, and if you consider all this produce less equal error rate. Comparison of input length. If you say the typing pattern can be more accurate if you give a long paragraph, Okay, a long paragraph of typing. It is not the correct. So input length, if you increase the input length according to this 1, 2, 3, 4, 5, 6, 7, 8, up to 10, that will saturate. Equal error rate means the accuracy of your system. If you increase the input length, we should not think the accuracy will increase. Accuracy will, once it will be saturated. Okay, once it will be set after say 7 characters, it will be saturated. Okay, now comparison performance of repetition. As that I told you, while preparing the data set, repetition of the text is very important. It does not mean if you type the same text many times, it will give the equal error rate very low. This is not the correct statement. So repetition is a method up to certain times. So 5 times repetition, 10 times repetition, all right. If you go beyond this, it will not give anything else, anything much. So this is the study. What are the factors? These are the 4 factors that influence the typing pattern mostly. One is the nature of the text, complex, numerical, simple text. While considering the feature element, timing features, what are the main features that influence the uh, result? These main features are all features combining together. Down latency, hold latency, up-down latency. These are the only 4 that you can consider. And comparison of the input length. You do not. We should not think that if we type long text that will give the better histodynamics accuracy, because our typing pattern remain confined within this 26 alphabet and up to some numeric and non-numeric characters mostly. So means a long text cannot always perform better. Comparing performance for repetition in training, repetition always does not reach much better. Up to 5 or 6, maximum 10 is enough for the study. This is the uncertain change. Okay, uncertain changes of feature values in a session. Okay, so this type of change may occur during typing. Okay, so it is a hold time, down time, is key hold time. Session 4 means 4, session 4, 5, 6 means these are the various volunteers, various persons who have down. So these are the variation in various feature vectors with repetition. Okay, the variation is with some repetition. Okay, this is the nature of variation. This input is the this is the name of data set. So intra-class variation. Within the, if you type in the morning, you type in the evening, this variation will change. Variation may come. Intra-class variation. Your typing pattern may not be always the same. Okay, if you consider it with up to the order of 10 to the power minus nanosecond in case of the sensors as built in within your smartphone. Next, research goal and contribution. So for this column median growing window template formation technique we shall use here. Validate the proposed model achievement of Canberra distance and large number of shared dataset. Compare this model with previously implemented fifth anomaly detector. Identify adjustment for improvement performance. Now, proposed model for entry point access control. So this is the raw sample. Okay, this raw sample is divided into various windows. This is the purpose of feature extraction. Then concatenated features values. Then growing window technique we apply here. Then the with using column median without taking the mean value of various column values, we have considered the median because mean value can sometimes give the lot of change. So this is the template formation. This is the unknown sample will, this claim sample will come. It will go through this similarity score and take the decision until the score is reaches some threshold, allows or it is not. So this is the training part, this is the testing phase. Here participants kindly, am I audible to you all? Visible my transparency? Kindly? Hello? Hello?
Yes, sir. Yes, sir. Yes,
Yes,
sir.
sir, it's visible.
Visible? Okay. Thank you. Now, performance of the Canberra with proposed template permission and adaptation. This is the how the uh, Canberra anomaly detector performance. We have studied the performance out of this 50 anomaly detectors. Only Canberra perform much better. The equal error rate for this anomaly detector is very less. Equal error rate is the parameter that can judge the accuracy of your model. So it is our data set, the box plot, this mean, this median value, rate is the mean value. This is the standard deviation. Upper one is the mean. So this is the nature of the box plots and its parameters. These are the outlier counts. Sometimes some values go beyond some range. That is the certain variation in histogram. This is the how we have analyzed the data set. So out of this, we have seen that Canberra with column median technique gives the better performance for the all data set. The performance of various anomaly detectors has been produced here with the approaches with column median technique, out there count with column median technique, Canberra, distance, etc. This is the scale manager. Distance, this is the base value is equal rate. This is the name of the data set we have considered. Okay. The equal rate is a parameter that gives the indication how accurate the model is, how accurate it is. The comparison with various type of performance anomaly detectors. This is the point. With the template formation with various session. 6 sessions we have considered here, and each session we have this repetition 2, repetition 3, 4 repetition, 5 repetition, 6 repetition. If you see that this has been considered, this has been reached the saturated, that is converged here. Performance of the suggested technique for a certain template and input of recurrence during testing, the results shows that a higher template with fewer repetition is always better for lower equal error. Higher template, higher template with fewer repetition is better. Say fixed template with fewer two repetition two is achieve the lowest equal error rate. Research gap, longer data acquisition in training suggestion and equation study takes time. Huge battery consumption for operating sensor for longer time. Data acquisition at a higher sampling rate. This research goal and continue analysis the performance analysis detectors. So purpose for 4 unique schemes to accelerate performance detector baseline performance. Develop a data set with more advanced sensory feature. This is how the data set is prepared. This is an app. We have developed an app installing in any mobile phone, and if you go on typing, you will get that how the data is going to be stored within the sensor. Okay, within you have to name here this accelerometer. Okay. The sampling rate is in hertz, device Moto G plus, subject 8:7, session is 2, repetition is 6. Okay, duration is 1 second, 1.2 second, 3 second, 3.5 second. Okay, we have asked one person to type within 1 second, within 1.5 second, within 2 seconds, within 2.5 seconds, 3 seconds, 3.5 seconds. Okay, this is the various parameters of preparing the data, how the data set has been prepared. This app has been prepared. With the app, the mobile phone has been supplied to the volunteer to ask his or her name, his gender, level of education, age, etc., and type some fixed text or sometimes some dynamic text. So accordingly, the data set has been prepared. This is the two thing has been amalgamated to make the data set more powerful. One is the features vectors of typing pattern, say keyhole time, up down time, down time, up down, etc. These are for the timing features. Features vectors of histodynamics. With these feature vectors, we have incorporated the timing, the sensory features. Various sensors features have been incorporated together. So data has been more powerful. The one side is a sensory features, other side is a timing features. Both has been joined together. Okay, to have the better performance. This is the sliding window technique. A total typing pattern has been divided into various equal parts. The timing domain specific, and each specific is of same length in time in text or same timing features, all of same time duration. This is the sliding window technique. A large typing pattern has been divided into various equal parts. Consider the time or consider the content of timing features. This is the sliding window technique. And various statistical parameter has been calculated, which are minimum, maximum, average, standard deviation, median, Q1, Q2, cuteness, kurtosis, etc. And a comparison of the baseline and other parameters. Baseline is state of the art method. Median template, augmented sample, software metrics. Augmented sample means this small number of samples can be augmented mathematically to produce a large amount of sample. That will not hamper the result at all. Okay. Median template, without considering the mean, median of the values of a particular template has been considered. Now come to the one term soft biometrics. Soft biometrics is the added features to a human being that can isolate him temporarily from the among the others. Okay, that is a soft biometric technique. It has been seen that soft biometric technique gives the better accuracy, in all the time. Okay, soft biometrics is this. Suppose your friend is coming by, say, Rajdhani Express from coach number, say, C1. You have not seen your friend long time before. So your friend has told you earlier that I have a hat in my head. So when he calmed down or she calmed down from the coach number C5, you will find out how many person calmed down with a hat in the head. Say 5% has come. Total say out of 500 person, the 5% has come out with the head at their head. So out of the 5, you have to search your friend. So the whole database searching page initially was 500. The 500 people, say, suppose come down from that specific code number C5, and without searching this 500 people, you just search 5 people. Who is your friend? So this searching complexity gets less, so accuracy becomes higher. So this soft biometric techniques, similarly, grossly the same as I produced you as an example. So it is this, the increase the accuracy. We shall show you in our transparency and studies that this soft biometrics, incorporation of soft biometrics, increase the accuracy gradually. Okay, you have multiple soft biometrics also. Okay, somebody has say he has come down with a hat in his head, with pant and coat and tie easily. You can use the technique to identify the person. Now, the proposed method, this is the sample. typing sample, windowing it, preprocessing the data, and this technique, RANDIF sample with minus E randomness, you can easily increase the augmented data. Data can be augmented n times. Fx is the fx is the x is the sample. Okay, so x total sample n times increase with this RANDIF function that you all know. Then this augmented sample has been trained with auto-encoded deep learning technique. Okay, trained with this deep learning technique. Now the claim sample has become here. It has been tested, and anomalous code has been calculated. Consider anomalous score. This is will be taken up to some threshold you will allow, up to some threshold you will. This is your usability control. How much you will allow, how much you will not. This, on the other hand, is a continuous capturing of data, is continuous authentication, continuous training of the sample. Okay. Now, next performance of the autoencoder, baseline, equivalent, access, all the statistical parameters has been calculated to make the things very easy. First, will be at first. So, duration and its fixed effect towards the performance. So, 1.2 seconds, 3.2 seconds, 3 seconds, 3.5 seconds, all these standard deviation, p-value, different p-value has been calculated. All statistical parameters that acquisition, duration as impedance factor, keystroke based, is done with the screening. So, issue is this bootstrapping sample. How to handle an imbalanced data set? Imbalanced data set, always health data set. Healthcare data set is normally imbalanced data set. Suppose say a lot of patients, you have few person has been detected for some specific disease. So that minority class should not be neglected. Minority class should be considered very importantly, accurately, so that information can come out from that minority class. There is a main point of concentration. This is a superpopulation. Bootstrapping sample is created in this form. All these bootstrap sample has the one or two or not equal number of minority class. Rare samples are ignored, and imbalance class distribution is there. The result is not so equivalent because the sample with which it has been trained and sample is going to test the same thing. I would like to say the same sample which has been trained with the same sample which has been going to be tested. So the accuracy always should not be so high or so believable. Okay, presence of several samples in multiple sessions with repeats overlapping sample in both training and testing set. This is the issue of predictive model. We have to predict something. Now, propose a bootstrap-based homogeneous ensemble approach without ignoring the rare samples for more accurate and robust predictive model to extract useful information from typing habits. Evaluate the proposed model with more realistic model, evaluating using leave one user out cost validation. Leave one user means the user will not be trained. Okay, while testing that will come. LO, U or CV, leave one user out cross validation for practical results. This is the bootstrapping sample. In our proposed model, all these bootstrapping sample prepared from this superpopulation has contained all minority samples. So this is the superpopulation. These yellow samples are say has Parkinson's disease. While preparing bootstrapping sample, all these bootstrapping sample has the same number of all these number of minority class means this person with patient with Parkinson disease. These are our balanced sample. Here in our technique, the new technique we have used here, all of these are balanced sample. Sample 1, sample 2, sample 3. Next come to the bootstrapping based homogeneous and sample technique. Here the raw histogram data, windowing technique, sample 1, sample n, feature extraction. This is the level in training sample 1 and 0. It has, it does not have, it has, it does not have. Parkinson sample preparation. With this sample preparation, minority class, majority class, bootstrapping technique has been used. With all these bootstrap samples, the minority class has been attached. So these are the sampling, minority class and the majority class, minority class, majority class, minority class, majority, all these minority class has been attached to all of this sample. Now it has been modeled for validation using cross validation for selecting better features, best features. The machine learning model, machine learning model, machine learning model trained. Different machine learning has been applied. With this machine learning model output, majority voting technique has been considered. With this majority voting technique, the final 0 or 1 final predicted level has been prepared. So this is the test sample. This is already training part. Test sample has come, feature extraction has been done, and with this feature extraction, best feature has been fed here for this technique and machine learning technique, majority voting technique. You have predicted the model. Okay. Now come here. These are the various type of repetition. So this color is test sample. This color is training set. This color is minority class. This color is majority class. Here A is only the test sample, other are the training sample. So here B is the test samples, other are the training sample, and so on. Okay, so 111 which predicted score is sample 1. Test sample is 111. Actual level is 111. And this is actual level, sample B is 000. Predicted score is like this. What is above 50%, we consider it 1. Below 50%, consider it 0. It was 0, now it is 1. It was 0, 45%, now it is 1. Within this, true positive, true negative, false negative has been calculated. Out of these parameters, here predicted level has been decided in this manner. If your actual level was this, predicted level is this, and the confusion matrix has been calculated. With this confusion matrix, accuracy can be easily detected. And these are the age group detection. This T is the timing feature, P is the pressure, R is the rotational characteristics, S is the statistical pattern, N is the natural timing pattern, etc. In our case, we have used this LOUCV. So it can predict the age group, child or adult. Typing pattern has come out from the child, the typing pattern of adult. This can be predict up to the accuracy of 93% from our model. Okay? So gender prediction. Gender prediction can be done not very accurately in all the models. Try to understand. Here only 2 gender has been considered, male and female. And we have already tried with transgender also. But gender prediction in case of typing pattern is not very accurate with all the models that has been, what we have found, okay? Now, handedness, left-hander or right-hander. A person who is typing is left-hander or right. That can be predicted up to the 97% accuracy. So all of the typing pattern, the model can predict whether his typing pattern is left-handed or right-handed. Hands used. How many used? Hands used. Some people use one hand in case of typing. Some people use two hands in typing. In case of typing. In the case of typing, not only the typing press down, key press up, down, latency are not only used. Used also various sensory features. Rotation, acceleration, gyroscope, gravitometer, proximeter, all of these data together conclude whether your handedness is one hand, you type in one hand, or both hand. These are various models. These are various models. So qualification means not qualification level of education that can be measured in various ways, but in our case we have up to college, post education. So present data set is this 222 present 87 was volunteers to present these are the thing and this can be predicted at 91% accuracy. Okay, so trace detection. So typing pattern can always change according to your mental state. How much mentally loaded you are. Okay? So mental load is high. We call the your stress is high. Stress or calm mode, mean cool. Don't have any mental anxiety or excitation at that moment. So it is the stress detection that can be detected up to the 99% accuracy for all of these models. Okay? Next, Parkinson disease. So Parkinson disease nowadays is very well studied, very well known, very bad neuromotor disorder in human being. It cannot be detected in the early stage normally, doctor says it. So this Parkinson disease can be detected with the typing pattern. We took it in two stages. One is no Parkinson, another one is the de novo, means Parkinson has been detected but without taking any medication. Next one is early stage, means the Parkinson has been started and the patient is taking the medicine. Only these three type of patient we have considered. This number is 42, 43, 40, 18, 15. This stands for with 42%, 42 patient with Parkinson and 42 patient without Parkinson. So this total number is 87. Okay, features are timing features, exhibit. Method is exhibit technique. Evaluation method leave one user out cross validation. This can be measured with the area under the curve parameters, specificity, sensitivity. These are the things. 88% accuracy, 84% accuracy can be detected. So application area, auto profiling for that. Auto profiling user, human computer interaction, forensic studies, surveillance, age specific access control, and age and gender specific content or advertising, soft biometric test for improvement of the performance. The soft biometrics I told you earlier, soft biometric tests are those characteristics that provide some information about the individual but lack the distinctiveness and permanence to sufficiently differentiate any two individuals. So, but on the other way, you can say the soft biometric traits are physical, behavioral, or agile human characteristics, classifiable in predefined human complaint categories. These categories are unlike in the classical biometric cases established and time proven by human with the aim of differentiating individuals. Now, method for incorporating trait to understand the impact. Without trait is called baseline method. The baseline model based on only primary biometric pattern. Here, no trait information has been incorporated. Manually imported level. Here, we incorporated the actual score manually. Say male equal to 1, female equal to 0 for each trait. Automatically imported predicted level. Here we used automatically generated predicted level using predictive model for each trait. Automatically imported predictive score. Here we used an automatically generated predictive probability score like male 67%, female 53% for each trait. Automatically imported predictive score is here. Automatically imported predictive level and score combined. Here we use automatically generated predictive level and score for each trait as extra features. So here comparison of soft biometric method with baseline. Impact of predicting and incorporating trait in verification in static mode and comparison with the baseline model. Scale Manhattan is the technique where we have used the without trait is this, manually incorporated trait is this, predictive trait is this, predicted probability is this, and combined is this. This is the equal error rate. Bracket is the standard deviation. B indicates significantly different with baseline. Okay, the baseline means without incorporating any trait. Okay, so without incorporating trait, the results gradually changes. So here scale Manhattan, 1 plus SBM, Manhattan, outlier count, Bhattacharya distance, equivalent distance, these are all 1 plus classifier, means binary classifier. This say yes or no, only the trait. This has been studied and impact of predicting and incorporating the traits in verification in dynamic mode. Means you are typing not a fixed text, whatever you like to type in your system. So here is the impact of incorporating traits. What I would like to say that these are the various anomaly detectors, means 1 plus classifier and binary classifier. Here, these are the various data sets. Here are the various soft biometric traits. Okay, various soft biometric traits. Okay, so with the incorporation of these are the each color corresponds to each biometric trait. So if you incorporate the soft biometric state, you can see that equal error rate is gradually this x-axis is the equal error rate. So the incorporation of each biometric state in each set of each data set, in each case, each classifier, this increase the accuracy, means make less the equal error rate. All the cases is true. Incorporation of soft biometric traits make the equal error rate very less. So incorporation of soft biometric trait increase the accuracy of the system, make the system more and more robust. Okay, this we have proved it, we have applied it in various systems. Protection of kids from the internet threat. So sometimes the kids are going to the internet site, adult site sometimes for the curiosity and interest, but to protect the kids because the typing pattern can be checked, whether it is of adult, whether it is for the child. So in the machine we find the typing pattern is from children. It can access control. It will give some access or not access to some sites. in the internet. This is the protecting kids from internet threats. So anybody can protect it. The moment a user is identified as child or minor or next stage of the protection will be an auto-sensing firewall appropriate for the user. Key finding after extensive research work using sensor technologies, we extended the accuracy to 93.21% for the smartphone. Implication proper use of histotype attributes can protect kids from internet threats and can be used to develop age-restricted access control in any system. Mental stress diagnosis at home, stress dataset developed by this and features sensory and statistical proposed. This is the class, trace and come. So sampling features all this male, female and age, average age data division is this. Okay, so this stress detection can be monitored also in the home environment with the help of smartphone. How much stress you have in your mind. So Parkinson disease is a very severe neurodegenerative disorder which affects motor control. Parkinson's disease is the second most common neurodegenerative condition after Alzheimer's. One of the most difficult to identify disorder since there is no biomarker to quantify the Parkinson's disease. Presence of presence of motor symptoms such as tremors, bediness, stiffness, postural instability is used to diagnose Parkinson's disease. This is a progressive illness. A precise diagnosis of its symptom is important for better treatment. Unfortunate thing is that this disease cannot be detected in early stage. Present status and progression of the disease are also required for Parkinson's disease symptoms. Early screening has significant advantage for diagnosis and preventing its consequences. Present medical practice has limited tools for frequent, quick, cost-effective, and burden-free clinical diagnosis for the Parkinson's disease. Challenges: no single test that can effectively identify Parkinson's disease activity. Parkinson's disease is the early stage, is difficult to quantify due to mild symptoms. Where is my phone? Okay. Here. Okay. So many of the clinical deficits are common with other disorders such as progressive supranuclear palsy and sponiocerebellar ataxia. Majority of new doctors fail to detect Parkinson's in the early stage. Okay, affect the more time efficient than other method, which is nevertheless used in lab environment in the presence of expert. Limiting its use commonly continuously over a longer period of time. As a Parkinson's disease is progressive disorder, frequently diagnosis is essential for better treatment and therapy management. Parkinson's is at the earliest possibility stage and continuously monitoring the patient's mental status throughout the day and every day, it would be more interesting and beneficial. These are various challenges regarding Parkinson's disease. How does it occur? This is the chemical, specific chemical dopamine. When the dopamine production is very less, when two neurons communicate with each other, when the two neurons exchange their signal among each other, this dopamine is the most important communicator between them. When this chemical, dopamine, is less, production is very less, then it is thought, it is believed that Parkinson's disease has occurred. This is a normal situation. This is the Parkinson affected neuron. It occurs in the substantia nigra part of the brain, mostly whole body that's controlled with the knob, substantia nigra. It has much more study in the neurobiological manner. We have not gone the details of it. Now, key objective, propose the keystroke dynamics-based Parkinson disease indicator, which daily typing habits or home screening address the six key hypotheses related to our main objective of this is the screening process. Proposed method use a series of keyhole time and timing gap between the consecutive press and release as a feature set. These are the two timing features mainly responsible to detect motor neuron disorder. A wide range of statistical tools were employed to create a machine learning ready features from split pattern. A homogeneous ensemble learning approach was then developed using bootstrapping and undersampling for classification. Model was validated using the fixed text and free text input obtained from early stage Parkinson disease patient, neo Parkinson disease patient, and healthy control. Early stage Parkinson patient disease means a patient, Parkinson disease patient, whose Parkinson disease has been detected and he is under medication. This is all we call early stage Parkinson disease patient. Neo means whose Parkinson disease has been detected, but the patient has not started medicine yet. Healthy control means who does not have any Parkinson has been detected. Health normal people. Okay, so these are the various timing features that I've shown you earlier. Use statistical features, various statistical features. This is the whole time going through, and every time this latency, press latency. This is the RR latency. These are various timing features. This black is healthy control. This is with Parkinson. This is make the blocks plot. The whole time mainly affect. It all mainly affect the whole time. This whole time in median, whole time in with standard deviation, whole time with mean, whole time with max, and it has been studied all the statistical features Parkinson versus healthy. This black is Parkinson's without healthy one. This brown is Parkinson. Okay, so these are the result fixed test input observed area under the curve is 85%, almost 86%. For the free text, it is 78%. Area under curve is 79%. Area for detecting early stage is 83%. These are the performance of this. Combined means here consider all of these features. De novo means this. So it is the detecting accuracy of Parkinson disease with the keyhole time mainly responsible. Okay, now impact of feature selection. All features, whole time features, press, release features has been considered. This is in case of combine, de novo, early stage. Okay, so these are the various thing has been studied. The area under the curve, the accuracy, the area under the curve is this. So this is the these are the or W1, W2, W3, W3 various windows has been compared, etc. So comparison of machine learning models. So impact of text selection, which text you are going to type. Result of S indicator significant comparison text indicator. Various result, various way you have typed it and application area, online screening, cost effective, high collective power, no long lasting damage, no little effort or interaction, easy deployment. Limitation of the model. The strategy is not intended to replace doctors. Maximum area under the curve is 86%. Not well while user under mental stress. A person who has mental stress and Parkinson, this model will not work much, logically enough, not useful to the age group below 18. Not well while working, memories be busy with other job. Not well while you are giving data and when your memory is busy with other job. Not well for short input length, only numeric input. Not well for input composed of with short syllabi word. A long extra text should be given. Conclusion. Now you come to this, okay, so this is the model we have already, software we have designed that can helps to predict the whether it has Parkinson or not, etc. So let us try how this software works. I shall give you some Sandeep, how to make it close now. So I have to copy the link. I have to copy this link and have to place in the model. So if everything goes well, if server is not busy, I can show you how does it perform and give the result output. So I think it is visible to everybody. Hello, honorable participants. So I'm going to submit to, can you check the net is appropriate connection? So please, let's go to the থেকে চলছে নেটটা চলছে দেখছি আমার কি এটা connected. Please wait. It will take a bit time. Okay. This is the rudimentary version of the software Facebook. Here, there are a lot of data sets are there. This is a patient, de novo, who has been detected, means who has been detected as Parkinson patient, but he has not started medicine yet. So here, I would like to know, are you a Parkinson patient? So give some typing pattern here. I am giving some typing pattern. Verify. First time it says that healthy controls. Screening report based on keystroke analysis. The word I type, consider the typing pattern of this word. My software is saying I am the healthy control. At present, I do not have any chance to have the Parkinson disease, but it will give more parameter of analysis. So kindly wait for a while, keep patience. I do not have anything in my hand, it is in the server. Okay, so it is running from Chinese server. This app has been developed with Art Studio and Art Statistical languages and stored in a free SignUp server. From the SignUp server, it is running to show you some result about my typing, how much it is, how far I am from actual Parkinson. Okay, so this data set is well balanced and very strong enough with the 43 patient and 43 patient of various class. They have the Parkinson but not yet started medicine. They have the Parkinson have started medicine, and there are persons who do not have any Parkinson disease. 50% is there. So data set is well balanced and a This data set analysis will show you some result. Please wait. I do not have anything in my hand to make it first. It is running from the server. Participant, do you find any interest here? I just repeat here. With the help of typing pattern, we can monitor our health with various neuro disorder. We concentrated on three neuro diseases: Parkinson, Alzheimer, and wait, please. Parkinson or dementia. অনেকক্ষণ সময় লেগে যাচ্ছে। Please wait. Wait, please wait. Please wait a while. Just wait a while, please don't mind. This is a very complex software developed by my group. Stop the cover. Just a moment. Yes. Report has come. Input text was Kolkata. It is healthy control. Okay. Details report is given here. This message appears to be the result of an analysis of keystroke related to use typing the word Kolkata. I have typed only one word. You can type even a sentence also. It will take time to analyze, but as a short word, I just gave common word Kolkata. Based on this analysis, the user has been diagnosed as a healthy control. However, there is also a probability of 6.84% of having Parkinson's disease. I have typed it. I am healthy control of 83.16%, but I have a probability to have Parkinson's disease up to this age, up to today, according to this software, is 6.84%. The message then advise the user to schedule regular checkup to monitor their health as well as maintain a healthy lifestyle by engaging in regular exercise, maintaining balanced diet, generating good sleep, etc., etc. So this is the statistical pattern. Healthy person is this, 96% healthy, 4%, 2% is this, like this, it can go on. So this is the various type of timing features that I have typed in terms of millisecond. Okay, so this is the pattern. So this is red is healthy control. This green is Parkinson disease, and this one the test sample. Okay, a red is healthy control who does not have any Parkinson disease. Green is the Parkinson disease. These are the from obtained data set. This one I am tested sample has been provided here. So it is far away from the Parkinson disease. It looks so. So the sample statistical analysis is this, how this raw sampling data has been changed, in duration up, down, sample, etc. Box plot. Duration in millisecond, features are all here. Okay, key down, 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 up, down, key duration, latency. All the statistical features has been come out. Okay, all these features, press time, release time, machine learning studies like this, cross validation accuracy is like this, and these are the various classes, frequencies, and all statistical calculation has been done. That I would like to say, this is the uh, simple-minded technique that has been developed to monitor any motor neuron disease. Okay. Next, come to the other point. So, I have to go to the other part of PowerPoint of that. So, আরেকটা কোথায় PowerPoint? উপরে আছে। This is the another application that can be detected also whether your typing pattern is like this, say Control C. Participants, do you get interest on this? So it is the another application. Through typing pattern, you can, what are other things you can suggest? This is the model, verification in static model. Select the data set and so make the, there are a lot of options there, data summary, data visualization, anomaly detection, score fusion, database acquisition, etc. So come to the anomaly detection. So there are a lot of data sets here. I have told you out of these data sets, consider the data set that has been prepared with 3 seconds. At a time, the user has been given 3.5 seconds data duration. Data given duration, typing duration is 3.5 seconds. Out of the consider a machine learning algorithm means binary classifier. I have considered it. I have considered it here. Say scale Manhattan. Lot of others. Manhattan, autoencoder, Lorentzian, one class SVM, etc. If I have to run it, this is the equivalent rate. This is the skewness cutoff with t-test. This is the density plot. This is equivalent calculated in this manner. So these are the things, and if you use a, consider here another one class classifier, say one class SVM. Running it is running. One class classifier is very complicated algorithm. Equivalent rate has been come here. Okay, these are various parameters. Out of this, you can make here data acquisition, how you can collect data. Okay, Anasandi. So here you can enter your name. Here you can enter a text. Whatever text your gyroscope data is on. Okay. So these are the various parameters. Say type here something. Say Kolkata. Type here say Kolkata. Type here say Kolkata. Any text you can type, etc. Then make it submit. So your typing pattern, your keystroke dynamics has been stored here. All the features have been stored. What I have typed Kolkata, Kolkata, Kolkata. This. I am the male. I'm the left-hander. These are age group, etc. These are the various timing features have been captured by the dataset. So the dataset has been prepared in this manner. So I think I will conclude here. So questions and suggestions are equally welcome. Kindly ask me. Hello, hello, hello. Yes. So I think I have almost completed. Are you audible, sir? এখানে কি জানতে চাইছে? ও, প্রয়োজন যাচ্ছে এটা কি হয়েছে? টেক্সটটা কোথায় যে? Yes, লিখুন নাকি? হ্যাঁ, ঠিক আছে। Any point to ask? Anybody? Yeah. Questions? Dr. Vishas, you have any point? Any questions to ask? Yes. Okay. Yeah. Sorry? Once again? Yes, yes. Not from the back end. The software has been developed and has been installed in a server, and it is running from the server and producing result. The software has been developed with R statistics language, okay, and in the framework of Art Studio. What is your point then? Okay. Any faculty members? Any other faculty members? Do you have any point to ask? So you can, if I am not audible, you can type your question to me. Then your question in message also. Dr. Vishwas, any participant has any point to ask to me, please inquire them kindly. If I am not audible to you, kindly send message. May I upload some questions for you? Any participants, if you agree? Okay. Yes. Yes, madam. Yes. Why not? Yes. Alzheimer and Parkinson disease that can, but a person who has both Alzheimer and Parkinson, the system will not be able to respond accurately. Answer is this: system can alone distinguish a patient with Parkinson. System can alone distinguish a patient with Alzheimer, but a person who has both Alzheimer and Parkinson, that cannot be distinguished. In that case, neurological aspect will be much more complex that has not been taken care of by the software yet now. Are you happy with this answer? Anybody?
Yes, sir, satisfied.
Yes. Kindly tell me. Huh? Anybody? Yes, why not? Okay.
Hello, Manish. Principal sir will come. or I will be. So should I proceed? Okay. Okay, myself, Dr. Pranoti Rokit, Associate Professor, Computer Science and Engineering Department. I am. It is my privilege to produce my vote of thanks for this program. So I like to thank first today's speaker for his efficient and informative speech. And I then like to thank all the speakers of this faculty development program for their immense effort for this program. I like to thank our managing director, sir, passionate and effort for supporting this type of conduction of the FDP. I like to thank our principal sir, Professor Dr. Partho Sarkar sir, for his enormous effort and support for this faculty development program. I like to thank our convener of this program, Dr. Sitanath Bishes, HOD, AIML and CST department for his effort and dedicated, sincere support and conduction for this program. I like to thank Dr. Bikramjit Sarkar, HOD CSE, for his effort for this program. I like to thank all the coordinators, organizing members, and the technical support of this FDP. And I like to thank all the faculty members and all the participants for their passionate and what I say, for their patience to listen and engagement for this program. And nevertheless, I like to thank all the persons who are associated with the program. Thank you all. If I forget to name some, forgive me. So thank you all. Thank you. Over to you, Monish.
Thank you to one and all present here for joining us for the past 5 days. I hope I am speaking on the behalf of everyone when I say that all 5 days we have learned a lot of new things. As a student, I am currently doing my undergraduate, I am in my third year. And this was really insightful because I am somebody who is really passionate about artificial intelligence, and I am also an aspirant for getting my PhD in the same field. This is really something that this knowledge wouldn't have been accessible to me if I wasn't privileged enough to join this in the first place. So my heartiest thank you to all the speakers who joined us for the past 5 days. Thank you to all the participants who encouraged us and were with us through thick and thin. Thank you to my HOD, Dr. Shitanath Biswas, who is unfortunately not present today. Thank you, Dr. Bikramjit Sarkar, HOD CSE Department. Thank you, Monish sir, for giving me the opportunity to be here and host this event for the past 5 days. I'm really thankful. Thank you. That would be all from my end.